Here I've got a HAYEAR, which sounds like I'm admitting to a medical condition, but no. I've got a HAYEAR 2307D camera here that's used on my workbench as a kind of close-up camera, microscope camera. I bought this off Banggood just before Christmas, I think it was last year. It's been great. It came with an arm and everything as a full kit, and I use it to record to the micro SD card and then bot that into my editing software and use it for videos. One minor thing that bugs me a little bit, and I wonder if it could be addressed, is it doesn't record sound. Not quite. What I've noticed is that on the footage it records an MP4 track, and in the audio track, because there is an audio track on the footage, there's a 32 kilohertz track there, in I think in AAC format, and I've observed that there is definitely noise there, as if there is an analog to digital converter present on the chipset in this, but there's no built-in mic and no mic input. On other models I've seen that sometimes on the back they've got a mic socket. So I'm wondering if, because there seems to be some kind of analog to digital stage definitely going on in the chipset on this camera, if there's any way it could be modded to take an input, even if it's a socket for a lapel mic or something. You may be thinking, well, you've got a lapel mic, you're wearing it, why would you be bothered about an audio input? The reason is it would make synchronizing audio to video much easier. When I synchronize my lapel mic to the Canon that I'm shooting this on, the Canon also records sound on stereo mics. In fact, I used to use the sound directly from the Canon without too much trouble. Now that I've changed my workbench setup, the mics are not quite as ideal for my voice recording, so I decided to go down the lapel mic road and a separate little recorder, and the results are much better. I'm much happier with them, but it's made a lot easier in the post process to synchronize a video with an audio track and a separate audio track, because that can be done automatically. There's an option in the software that will do it really quickly, and I believe in a lot of editing software. I use Shotcut. I believe in a lot of editing software. If it's a bit more capable, there are things that will automatically sync them. Even if not, if you have to manually sync them, it's much easier and quicker to sync something. Even if you've done the clap, it's much easier to sync something that has an audio file for each thing you're trying to sync, rather than audio and picture, where, for instance, you have to tap something or flash something or whatever. I don't mean that in a rude way, but I want to have a look inside this, because I am curious to see, as I say, if there's any way I could add some kind of mic or audio input, because it would make that a heck of a lot easier, as the functionality seems to be halfway there. I've also not seen anyone take one of these apart. There's a kind of flat model that's quite popular, probably not HAYEAR branded, but probably comes out much of the same factory, that I have seen people take apart, but I haven't seen anybody do a teardown of one of these. I saw someone do a teardown on a website of one of the models with the built-in screen on the stand, and that actually had the circular layout on the board for a mic capsule just to be put straight on it, and it just wasn't there. So there we go. Okay, so looks like I've got the cover over the sensor, by the way. So, okay, interesting. We've got brass standoffs there, also on the front as well, and two ribbon cables. One goes to the button and power board, and goes right through the case, goes into this board, which is a connector board, and then there's another one going from that to the camera sensor. So we can see on there a Novatech chip, which must be the main controller, and a HAYEAR marked chip. I wonder if that's the firmware at the side there. I'll try and get a better shot of these. And I've just seen it. On the side, there it is. There is two pads, and it says mic. One says mic, one says speaker. Mic and SPK. So, wow, that was potentially easier than I thought. That's amazing. I want to try running this and experimenting with an input on there. So one of those is marked negative. I'm assuming it's got to be ground. Let's get a meter out and see. I probably should power this up and check those actually to see if there's any bias voltage, because if that's for a little condenser mic, it may have a bias voltage. If it's for a dynamic mic, it probably doesn't. Let's just see against the shield. No, it's not connected to shield, so I wonder if there is a bias voltage there. Are there any? Oh, there's a tiny battery as well. Just going to pause here a minute to make a quick correction in post. I went on a whole thing about this being a battery and being difficult to change and all this, and it turns out when I actually researched it later, it's not a battery, it's a little 3.3 volt, 0.22 farad supercapacitor, so it recharges. So it's not a battery, you don't have to worry about changing it at all. Anyway, back to the video. Alright, this is a bit of a lash up, but I've got the camera powered from my bench power supply into the USB. You might just be able to tell there's a little blue glow of the light there, and it's just about responding to the remote control presses. So I'm going to put it in movie mode. The SD card is in it. I'm going to press the OK button. Hopefully, yes, there we go. That little blue light will start to flash, which means it's recording. Now I went through my stash of stuff and tried to find a little dynamic mic element, because I measured across this from ground to each pin and across it. Couldn't find any trace of any DC bias voltage, so I think it just takes a dynamic input. So I know I've got lots of condenser mic modules, but I routed through to think if I could find a dynamic one, and out of a little old Sanyo dictaphone, a spares one, I found this little element which I actually had to clean up because it was covered in melted rubber from the old surround it was in, but I digress. I've tacked this with a couple of scrap wires into the recorder. I did a test where I set this thing recording and I was probing across the mic pins at the same time. When I checked that footage back and I checked the audio track, there was definitely a buzz where I'd probed the pins, so that input I'm sure is active. If this is working, it just might pick up my speech at this point. So I'm really curious to see. I'm going to say hello quite closely into it. I'm going to stop the recording again. So the light should go a solid blue, and it did. I'm going to power it off. It's fortunate that it is actually responding to presses, because the sensor's on the back of this, but it's just about reflecting off the edge. I'm going to unplug the USB from the power supply, so I don't want to shut anything out. Take this card out, put it in the computer and see if there's anything on the audio track. Alright, a couple of days later, a bit of an experiment is going on. We have a bit of a prototype here. So yeah, it turns out it's not quite as simple as just putting a mic capsule across those two terminals. I've opted to do an electric mic setup where you need to power the mic and then you take the output from that via a resistor and capacitor. And I first experimented with a 9-volt battery, and I got really good results from that. Then I thought, well, the most convenient thing to do would be to tap the 5-volt supply inside the camera, which comes from the USB and operates everything inside, to tap that, to use that as a power supply. And it didn't work because I may have mentioned before, I realised that there isn't ground continuity between that negative terminal and the actual ground, meaning that that input is isolated, or it expects to be isolated. If you're doing it from a 9-volt battery, there's your isolation, no problem. But if you try and power the electric mic from the 5 volts in the usual way, you get an awful overbearing motorboating noise. It picks up all the interference from the USB. It just doesn't work properly at all. So I was trying all sorts of things to try and sort that out, and what I've gone for in the end is I raided my spare parts buckets and all sorts, and I've done an isolated supply and a regulated supply. So we've got a 5-volt DC to DC isolator here, and then just here, hanging off there, is a 3.3 volt regulator. The isolator does most of the work, but it does leave some ripple behind, and it's quite low frequency ripple, and no amount of sticking capacitors on it and all sorts would sort it out, because it seems to be whenever you ground to the actual USB ground, it just has this terrible noise right throughout it. So I had to use the isolated ground to connect to the negative side, and then to get rid of that last bit of ripple, I ended up again going through my parts and finding a 3.3 volt regulator, which just flatlines that voltage out just to supply the electric mic with its bias current. And there is some noise on it. There is more noise on it than if you use a battery. I thought about this and figured that it's more important for me, it's more convenient for me to be able to power this internally from the camera and build all this onto a tiny board and stash it inside the camera, because there's room to do it, than it is to maybe stick a box on the side of the mic stand, the camera stand rather, with a 9-volt battery and a wire coming out of it. You could do that if you were really bothered about the noise floor, but again, this isn't going to record in the highest quality. Our goal is to make it record the audio good enough that the editing software can match it to the proper microphone sound and say, yes, that's the voice print, that matches the other sound, and it will automatically do the alignment. That's the whole point. So I've opted to do it for the noisier but more convenient way. I'm going to build all this down to a tiny board that we're going to slot into the camera, and then I'm going to drill a little hole, I think, above the micro SD slot, because right here there is a void in the top of the camera case where I'll be able to route the fine wiring from the top side of the board where the mic terminal is, and then into this slot. I could have done it on this side as well, but then the mic would be on the side of the camera. It might as well be on the back and be on the top, I guess, when it's pointing down, and just be in that spot there. But that to me seems to be the best way to do it. I even tried running it off the 12 volt supply. I tried running it from a 12 volt battery. I tried different USB supplies. The circuitry in this camera just creates a lot of noise. So isolating it and regulating it like that with what I've got on hand was the most effective way to do it for me. So I'm going to build this little board, see if we can make this all go inside. Alright, this tiny little board is what we've ended up with. So this is kind of tacked into the camera at the minute, so it's a little bit hard to show. I'll probably show some pictures. I think what I'm most proud of, apart from cramming all this on, is on the back of the mic capsule here, which is just sort of secured down, partly with this little blue piece that goes over the top. But what I'm most proud of is at the back of that, there's, from the bottom, there's a solid core piece of wire that formed the mic ground. It just sticks up through the bottom, and I just managed to get in that gap a fine soldering iron. I had to cover this plastic DC-DC converter with a bit of Captain tape to do it. But just managed to get the fine soldering iron in behind that mic, to solder the piece of solid wire to its negative terminal, which kind of held it in place. And then the rest of it is kynar wire, which I've just coloured with a couple of Sharpies just so I can identify which is which, because I haven't got any coloured kynar wire, I've only got white. But yeah, just managed to cram this together so that little 3.3 volt regulator module just fits on there. Then they're connected through to the bottom. There's a resistor across it just as a load. I've just tested this as it was kind of lashed up to the camera, and it works. The noise is a bit lower than it was on the breadboard. It's going to do the job, I think, just fine. The next thing will be to heat shrink it, so it's a shame it's going to get hidden, but heat shrink it and then work out the ideal length of these fine wires, tack those back onto the board. I've just undone it for the moment. But yeah, that's going to hopefully sit on top of here. This is the SD card slot, the SD card reader. So that's going to, when it's heat shrunk, it's just going to sit on top of there. I'll probably put a tiny bit of glue on it. Then in the back panel, I'll drill a little hole so the front of the mic can just aim at that hole. I don't think it's going to be that critical. But yeah, I think this is going to do the job. So the camera's back on the arm, and I've just got it pointing at a breadboard here. I haven't drilled a hole in the back of it yet, but I'm just kind of using this in the way I'd normally use it. There's 2 screws in the case, 2 screws out. As I say, I'm going to decide whether or not to drill that hole in, but I might give you an excerpt of what it sounds like in the camera here without the hole in. But ultimately, if it does the job of allowing the video editing software to pick it up and I'll line it up with the lapel mic, then I'm happy. I'm not going to bother drilling the hole. But if I think it will make it better, I'll do it. I've decided I'm not drilling no stinking hole. I'm going to leave it exactly as it is. Again, the point of this wasn't to get high quality audio out of it. It was just to get enough audio into it that the software could take the clips of the camera and of my lapel mic and automatically sync them. Then I use the sound of the lapel mic. And I've just tested that and it just worked perfectly. It did exactly what I want. I actually quite like that it's kind of hidden inside the camera, and there'd be no giveaway that I've made any kind of change to it at all. I'll put the circuit up at the end and a basic list of parts that I used. Hopefully this might give someone else, if you're thinking of doing this modification to yours, might give someone else an idea of trying this out. And if it helps you in the same way it helps me, I'm really happy. So that'll be all from me. I'll leave you with the circuit diagrams. Thanks for watching. Brucey bonus, just to show how this works. So you've got your video clip and your audio clip, and you see the HAYEAR video clip there's got an audio file in it. Make sure you select your audio one, click process and apply, and now it will reference that audio track. And there you go, snaps them into place. All good.